if we want to add new element into an array. So we need to have a large number of space to accommodate new element into an array. Once we move the elements from n-1 to p, next step is we have to insert a new data item at the position p. Size it was 5, now size is 4. Here because we have shifted all the elements from higher order to the lower order. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today let us start our discussion with the topics: operations on linear array, insertion, deleting an element from the array, and sorting. In previous session, we have learned different operations on linear array. Now here, today we are going to discuss the insertion, deletion, and sorting operations on linear array. Now let us move on to the next slide. First one is insertion and element. Insertion operation, as you know, the definition of insertion means a new data item can be inserted into an array at the given position. Now look at the definition. It refers to inserting an element into an array. A new element can be done provided the array should be large enough to accommodate the new element. Here, your new element, if we want to add new element into an array, so we need to have a large number of space to accommodate new element into an array. Next, when an element is to be inserted into a particular position, all the elements from the asked position to the last element should be shifted into the higher order position. So what is the logic behind it? Here the logic will be like this. For example, here this is an array. Let you take A. Let A be an array. Here 10, 20, 40, 50, 60 are the elements of an array. And here index S of 0, 1, 2, 3, 4. Here S is the name of an array. And here this is after insertion. So what is the logic for inserting new element into an array is, first of all, in this example, what is the size of an array? Here there are 5 elements. So we can say n, that is size is 5 because there are 5 elements. And index is S of 0 is the first element and S of 4 is the last index, that is the last element, that is 60 is the last element of an array. Now, if you want to insert a new element in this example 30, if I want to insert element 30 into an array at the position 2, at this position. If you want to insert a new element, example 30 into the position 2, means S of 2, the logic here is, first we have to move the element 60 into next position, next 50 should come here, next 40 should come here. So here first we are going to move element 60 into this position. So accordingly the position of the array will be, first it will be 10 as it is, 20 will be as it is, and we are going to shift element from last elements from here. So at this place 40 as it is, and this is 40, 50 and 60. In this example, we have to shift the last element 60 into the next higher order position. See, this is S of 4, so we have to move the element 60 to the next position, that is S of 5. This is S of 5, this is the index. So similarly 50 should be moved to the S of 4 and 40 to 50th position, or element 40 we have to move from S of 2 to the index S of 3. So here this is the process of, once if you move the element to the next higher order, the element to be inserted in this example 30, we have to insert 30 at S of 2. So accordingly it becomes 10, 20 and here we are going to insert new element, and 40, 50, 60. See, after inserting the element new data item element 30 into an array at the position S of 2, this will be the final array, or this will be the result of a new data item inserted into an array. So here if you observe this, what the logic we have followed here, from the last position up to this position means where we have to insert, in this example, S of 2. So here from last index S of 4 up to S of 2, we have to keep shifting elements, data items to the next higher order. Means in this example, 60 is S of 4, and we have to move that to S of 5. So similarly, we have to move all the elements up to this point. That is where we have to insert new data item or new data element. So after this, next step is we have to insert the new element 30 into the position S of 2. Now you observe this at the beginning. Here, what was the size of an array? Size of an array, it was 5. There were 5 elements. Now, after inserting a new data item into an array, the size becomes 6. So it is size n equals 6. How we got 6? It is n equals n plus 1. So this is the logic for inserting a new data item into an existing array. Now look at the algorithm for the same. This is an algorithm. Here A is an array with n elements. Item is the element to be inserted in the position P. So here item is the element to be inserted at the position P. Let A be an array of n elements. N is the size of an array. What is the first step? As we have seen in the previous example, see, from n minus 1 down to P. So we have to shift the element from last element, that is n minus 1, to up to position P. We have to shift the element. We have to move the element data item, that is A of I plus 1 equals to A of I. Then, and because it is in a loop, so all the elements from n minus 1 up to P is going to move to the next higher index. Then once we move the elements from n minus 1 to P, next step is we have to insert a new data item at the position P. So here A of P means A is the name of an array, P is the position where we have to insert a new data item. So here item is the element to be inserted. Next, once the new data item inserted, obviously the size of the array will be incremented by plus 1. So n was the size earlier, that is before inserting a new element, and after inserting a new data item into an array, the size will be n equal to n plus 1. So this is an algorithm for inserting a new data item into an array. Now let us move on to next operation, that is deleting an element from an array. Next operation is deletion. What is the definition? It refers to removing an element into an array. When the element is to be deleted from a particular position, all the subsequent elements should be shifted to the lower order position. It is reverse of what we have done in our previous logic. Let us take an example now. This is an array. Let it be A or S. S is an array of 10, 20, 30, 40, 50 are the elements. Size here n equals, there are 5 elements, n is 5 here. Now we would like to remove the element at the index S of 2, means we would like to remove the element 30. It is at the index 2, that is S of 2. So in that case, what is the logic here? As per the definition, here when the element to be deleted from a particular position, all the subsequent element should be shifted into the lower order position. See, what is the meaning of that? See, from here, from this point, that is from this particular point till the end of an array, till n minus 1, we have to shift to the lower order position, means to the previous index. For example, in this example, I want to remove element from this point, that is S of 2, that is 30. So next one is I have to shift this element 40 to the lower index, that is S of 2. That is the meaning of subsequent element should be shifted to the lower order position. Here it was index was 3 here. Now we have to shift this element to the index 2. Now once if we shift this element, so array looks like 10, 20, 40 because it is going to overwrite on the previous value. Next, after this, next element is 50. We have to move to the next lower order position or lower index. So from 4 to 3. So in that case, this element will be 40. It will be 50. Will move to this index, that is S of 3. So where the index S of 3 stores the value 50. So at the end of this process, we can make out that there are only 4 elements. So here size of an array is going to be 4. Here earlier at the original, before deleting element from an array, size it was 5, now size is 4. I mean here because we have shifted all the elements from higher order to the lower order. So in that way, how we got 9 here? Size is n equals to n minus 1. N equal to n minus 1. This is the after deleting element from an array, size will be reduced by minus 1. So this is the logic for deleting element from an array. Now look at the algorithm for this. Let A is an array with n elements. Item is the element to be deleted in the position P and it is stored into the variable item. So here, as we have said in the previous example, n is size of an array, A is name of an array, item is the element to be deleted from the array at the position P. Now in this example, first step is item equal to A of P. The element to be deleted, first we are going to store in the variable item. So that is A of P. Suppose at the point P, we have to delete the element. That element has to be assigned to a variable item. After that, for I equals P to n minus 1. So here from that particular point, mean from where we have to delete an element, from that index, that is from P to n minus 1 till the end of an array, till the length of an array, we have to move the elements to the previous or lower order index, that is A of I equals A of I plus 1. So it is A of I equals A of I plus 1. So this is in a for loop. So at the end of this loop, from the point P till the end of n minus 1, the higher order values or data items of the higher order will be moved to the data items at the lower order index. So this is in a loop. So at the end of the loop, the elements will be deleted. Then after deleting an element, size has to be reduced by minus 1. So that is n equals to n minus 1. N was the original length or size of an array before deletion. Now after deletion, size will be n minus 1. So we have to come out of the program. So this is the logic for deleting an element from an array at the position P. Now let us move on to next operation, that is insertion sort. Now we have learned the definition of sorting. What is sorting? Sorting is nothing but arrangement of data items either in ascending order or descending order. So here, how do we sort it? The definition says the first element of the array is assumed to be in the correct position. The next element is considered as the key element and compared with the elements before the key element and is inserted in its correct position. Consider the example. Here, let array elements be 70, 30, 40, 10 and 80. This is a given array, and if you observe that these elements are not sorted. Now let us follow the algorithm for the same. First we have to assume that 30 is in its right position. So next 30 is in its right position. Now look at 70. This 70 and 30. 70 is greater than 30 and 30 is less than 70. So accordingly, we have to interchange these two values. So first we have to compare 30 and 70. Since 30 is less than 70, it has to be interchanged. So accordingly, here the array elements looks like this now. The array looks like this. So we have interchanged these values 30 and 70. Now 30, 70, 40, 10 and 80 are the elements. Now next one is this 70 and 40. If you compare these two elements here, data items or the elements, 70 is greater than 40. So obviously these has to be interchanged. This has to be interchanged. So for that, then after interchanging these two values, the array elements are like this: 30 and here 40 and 70, 10 and 80. This is the element after step 2 or after second stage. Next, again you compare these two elements 70 and 30. Since 70 is greater than 10, we have to interchange these two values again. So after that, now 10 is the key element. Since it is less than 30, 40 and 70, it will be exchanged. Now at the first time, it is going to change the values. It becomes first 10 will be interchanged with 70. So array elements looks like this: 40, 10, 10, 70 and 80. Now, if you observe these elements, 10 is less than 40, it has to be interchanged. So, next step will be 10, 10 and here 40, 70, 80. Now, 10 is less than 30, again it has to be interchanged. So, it becomes 10, 30, 40, 70, 80. So now, after at this stage, the 10 is less than 70, 40 and 30. So 10 comes to its position, to its right position. So 10, 30, 40, 70 and 80. Now, if you compare 70 and 80, 80 is greater than 70 or 70 is less than 80. So there we need not to interchange these two values. So at the end of the process, the array elements look like this. So it is 10, 30, 40, 70 and 80. This is in sorted order, or all these elements of an array are sorted. Now let us see an algorithm for the same. Now, let A be an array with n unsorted elements, and the following algorithm sort the element in order. Here, first step is for I is equals to 1 to n minus 1 and j equals to 1, while j greater than or equals to 1. If a of j less than a of j minus 1, these are the steps for interchanging the values. And here we are closing while loop here. This is end of while loop and this is end of for loop. And here these are the steps where we interchange the values of, or we have to swap the values. So here in this algorithm, observe that we are using two loops, one loop inside another loop. This is called nested loop. And here inside the while loop, we are going to compare the two data items, and if one item is greater than or less than another item, that has to be interchanged. So this is the steps or logic to interchange the values of two variables or to swap the two values. So here this is the logic for, or this is an algorithm for sorting elements in an array. Students, in this session we have learned insertion, deletion and sorting of an element in an array. We will continue our discussion in my next session. Thank you.